It's the Cambrian Explosion.
Yep, that pretty much explains it. Video's over. I assume that if you've clicked on this video, you're vaguely aware of the term Cambrian Explosion, and probably the context that it's what we call a very early development in animal life. But what does that actually mean? Why did it happen? And why does everything look so weird? All in good time, but first, the basics. Earth is old. Very old. About 4 billion years old. You've probably seen this example at some point that shows how if the Earth's lifespan was a clock, where the Earth started existing at midnight, the origin of life is here, animals as we know them didn't even start existing until all the way over here, with the colonization of land happening about here, dinosaurs here, and humans developing all the way over here, about 77 seconds before midnight. That gives you an idea of the scale we're working with, but what we care about right now is this quarter from 3 PM to 9 PM. And most importantly, right at the end of it, the Cambrian period. Geological time is split into eons, eras, periods, epochs, and ages. And we're looking not just at the first border of the Paleozoic era, but the Phanerozoic eon, the one known for animal life. This is before there were mammals or birds, before there were reptiles or fish, this is before there were even bones. Before this period, life was very simple, consisting of multicellular organisms, but without the complex morphology of what we would typically recognise as animals. Then, apparently suddenly, fossils of all sorts of complex animals, unlike many things we have today, arose in the fossil record, showing all kinds of morphology that hadn't been there before. This is what we call an adaptive radiation, where there is a clear and noticeable increase in biodiversity due to some sort of evolutionary event. The Cambrian Explosion is one of the earliest we know about, it's definitely one of the most famous, and is arguably the most significant. In order to figure out what happened and when, we first need to look at what the planet was doing beforehand, and a little bit at the time too. For this we look at the Proterozoic eon, which was started by a length of time called the boring billion, for the fairly self-explanatory reason that basically nothing happened. We just don't have very much fossil evidence from around this time, but we do know that the oceans were not in a condition to support the diversification of eukaryotic life because it was full of sulfur and empty of oxygen. It stayed like this right through an ice age and the formation of a supercontinent, until an event called the Sturm excursion, where some sponges decided it would be a great idea to actually eat all of this delicious carbon in the water, and they started spitting out oxygen, which would eventually allow for more rapid diversification. And with that, our scene is set, as an ocean that is suddenly gaining much more oxygen, devoid of animals that would use that to its fullest extent. Prime conditions for an adaptive radiation. It's very easy to answer the question of what evolved with everything. And although that's a huge oversimplification, it is true that all extant animal phyla evolved during the Cambrian Explosion. We're not going to go over all of them here because there are a lot, and people argue about how they're great, but the ones you'll most likely recognise are sponges, jellyfish, mollusks, arthropods, and chordates, animals with spinal cords that would eventually produce vertebrates. However, they aren't the only things to appear, as several things that arose during the Cambrian Explosion just aren't around anymore. I'm going to briefly touch on some of the more easily recognisable Cambrian animals here, starting with Opabinia and this thing that no one knows how to pronounce. Anomalocaris, Anomalocaris, Anomalocaris. Weird shrimp. These, among other things, are recognisable for these flaps along their side and are currently classified as early arthropods. They're the biggest predators we know of in the Cambrian, sitting at a whole 56 centimetres. I cut off some slack, but this was the origin of complex life. We didn't even have fish yet, so the most likely prey were another group of early arthropods, the trilobites, which you've seen before. There's a paper about this that I can't access properly because academic journals hate everyone, but I'll link it in the description. Essentially, the proposition is that because Anomalocaris wasn't strong enough to crack the exoskeletons of trilobites, it abused an evolutionary chink in the armour by rapidly flexing them. They wiggled them to death. You know how if you unbend a paperclip and keep bending it back and forth it snaps? Imagine that, but to the actual animal. This strategy might be what led to the evolution of curling up into a ball as a defense mechanism in trilobites and later in isopods. Looking at Anomalocaris' cousin, Opabinia, we see that the dinocaridids are a prime example of evolution just kind of chucking things out there and seeing what sticks like a game of sport. Having 5 eyes appears to be one of the things that did not stick, and although this exact mouth appendage didn't stick around, similar structures would show up again in the form of a trunk or a proboscis. Another easily recognisable pair of Cambrian animals are Wiwaxia and Hallucigenia, which aren't directly related but do make good examples for the emergence of confusion in working out what the hell is going on. First, Hallucigenia. Look at this fucking thing. It looks like a child drew it, and then the reference design was handed to a paleo artist with the note good luck. This is what the Hallucigenia holotype looked like, and when it was originally reconstructed, these spines were interpreted as legs because creatures from the Cambrian were just that weird. We're fairly certain it's a type of lobopod, which, depending on the groupings, is the group that contains arthropods and tardigrades. You can see it. The legs are similar to what you'd expect from tardigrades, and the spines suggest the same kind of exoskeleton formation we'd already expect from Icthysozoa. The fact that I can describe it like this leads us to Wiwaxia. We fully do not know what this is. When we try to classify things, we compare species traits to the defining traits of the groups we're looking at, the synapomorphies. Synapomorphies are the traits originated in a group that are only present in members of that group, ranging anywhere from as specific as the feathers of dinosaurs to as wide-ranging as bones. The synapomorphies of annelids and mollusks are plentiful, but Wawaxia doesn't clearly fit the modern definition of either group, nor their Cambrian equivalents. Skipping the scientific back and forth that would take way too long to properly explain, the most recent take seems to be that it's more likely to be a proto-mollusk than a proto-annelid, but it's not like we have many alive proto either to study. Hopefully from these, you've seen two of the main issues with studying the Cambrian. The first is that, like all other ancient periods, we only have fossils to go from, so trying to classify stuff into modern groupings is difficult due to lack of evidence. The second is that, well, those modern groups didn't exist yet. Complex life was only just differentiating, and there were many groups that either hadn't fully differentiated or wouldn't even survive the period. Life looked very different to how it does today, so applying the same rules and groupings is impossible, and even applying the adapted version we use to work out how those groups arose is difficult. Answering this question is complex. Obviously we don't know for certain because we weren't there to see how it all went down, and there are several theories on how it all happened. Some of which mesh together, some of which conflict, and some of which make no goddamn sense. Broadly, the conversation comes down to whether the driving forces were environmental or ecological. As an evolutionary biologist, I tend to favour the ecological side of things, so I'll mostly be explaining that perspective, but I'm going to try and bring in environmental explanations too and see how they work together. The inciting incident, in all likelihood, was the increased concentration of oxygen in the oceans. As mentioned earlier, this was the Cambrian Excursion, brought on by the evolution of sponges. This allowed for the evolution of bigger and bigger animals, and the primary method of feeding switched from microbial mat feeding to macropredation. Essentially, they invented carnivores, and the world was never the same. In the primordial worlds of the Cambrian, the oceans were vast and clear and full of nutrients thanks to the Cambrian Excursion. Before then, euxinic oceans prevented this kind of development. Because of this, no niches had been filled. At all. In later evolution, the most specialised and therefore most unusual creatures are like that because they fill a very specific role, like anteaters. And several creatures evolve in the same way to fill similar roles, like dolphins, sharks, and ichthyosaurs, or our favourite evolutionary trope, carcinization. These niches exist entirely in relation to other organisms. That's the essence of what ecology is in the first place. So when there are no other organisms and no niches that have already been filled, no niches exist to be filled, so there's no real push towards specialization. Therefore, evolution starts just throwing stuff at the wall to see what sticks. And when there's nothing else on the wall already there, there's a lot of sticky wall available. This was before there were really any rules about what a body type could look like, because those rules only exist because of what survived the Cambrian. There was no rule that arthropods must have 10 limbs, because arthropods as we know them didn't exist. There was no rule about having 5 fingers per hand, because bones wouldn't even be invented for another few million years. It wasn't just the origin of complex life, it was the wild goddamn west of complex life. Anything was fair game because everything was new. And that's part of why we understand so little about it. Most of the rules that we use to classify life today just didn't exist yet, nor would they really be solidified until the Ordovician, the period after the Cambrian, where the end Ordovician ice age would kill half the planet in the first of the 5 great mass extinctions. After this mass extinction, there was an increase in biotic tearing, so organisms adapted to that as the niches became more well-defined. The groups of terrestrial arthropod we're used to seeing developed in the Silurian after that, and after the Devonian Nekton Revolution, the rules that would later produce most of the animals that dominate the planet today were solidified. These rules, and more importantly the fact that Cambrian animals didn't really follow them, are so much of why the Cambrian Explosion seems so weird and alien to us, and personally I think that's pretty cool. What's this? A secret extra section? That's right! Now that I've given what I hope is a coherent explanation about how the Cambrian Explosion happened, I want to give a thoroughly incoherent explanation of how it absolutely did not. Now I'm going to talk about my absolute favourite galaxy brain nonsense take about the Cambrian Explosion. Set-aside theory. Set-aside theory is simple. It's a way of explaining the apparently rapid radiation in animal body forms that we see during the Cambrian, and tries to answer the question of how did these come about so suddenly. It achieves this by using the science of epigenetics completely incorrectly. But before we talk about what epigenetics definitely is not, a quick overview of what it is. Epigenetics is the processes by which your genetic expression is controlled. Your actual genes don't change throughout your life unless you start chugging Phazon or something, but how they activate does. Not every gene is constantly producing what it codes for, and this is controlled with epigenetics. Essentially, is the gene switched on or off? Therefore, set-aside theory proposes that the genes controlling body expression did actually change via the normal process of evolution during the Ediacaran, the period before the Cambrian, and then some environmental factor at the beginning of the Cambrian suddenly caused all those new genes to switch on, leading to a sudden explosion of morphologies. This, in case you were wondering, makes no fucking sense. This is my favourite bullshit theory because it actively requires a total lack of understanding of how evolution works at its very base level, which is that selective pressures act on the phenotype of an animal to select for the most advantageous ones. If a gene is not expressed, It cannot be acted upon by natural selection, and the very core premise of set-aside theory is debunked in a single sentence. What's so much funnier is that there is no explanation needed for why the Cambrian explosion appeared to be so quick, because as far as we can tell, it just wasn't. It was very fast adaptive radiation, yes, but not impossibly fast. It appears faster than it was because of the fossil record and biases in it. Ordinarily, this would be incredibly easy to notice, as there would just be a chunk of rock with a weird absence of fossils in it, despite there being fossils on either side. It could just be chalked up to bad preservation. However, this bit of rock isn't there. To be clear, when I say the rock isn't there, I don't mean there isn't a layer in which the in-between fossils should be but aren't. I mean there should be a layer of rock with in-between fossils, but the rock is missing too. There's a chunk of the rock record that is just not there. It's called the Great Unconformity, and as far as we can tell, the rock is just gone. Eroded away completely as a result of multiple events along with any fossils it contained. So what did we learn today? Time is big. Very big. Very impossibly, incomprehensibly big. Even with models, it is impossible to truly comprehend the sheer scale of how long the planet and life have been around, and according to physicists, our solar system happened pretty close to the beginning of how long we expect the universe to be around. Nothing in biology is ever isolated. Adaptive radiations rely on environmental factors, but can also influence them. The Cambrian explosion wouldn't have happened if it weren't for ocean oxygenation, but that was caused by the evolution of sponges. The rules we use to classify life only exist because of what things from the random bullshit phase survived a catastrophic ice age. We don't know everything. There are massive gaps in the fossil record that are simply up to chance, since preservation is a process that requires incredible fortitude. Even when preservation does last until today, we don't know what everything is, especially when working out the ancestral forms of things that have had millions of years to change and specialise. Do your due diligence when putting together theories, and remember how the science you're studying actually works. Also, ask experts from other fields just in case they have any interesting input, but be prepared to tell them that what they're saying makes no sense too. Also, lack of evidence for a thing is not evidence for lack of a thing.